Hey everyone, this video is to talk about radians and converting between radians and degrees. So a radian is the angle formed when the radius is wrapped around the circle. The distance around the circle we call the circumference. And if you remember, our circumference formula is C equals 2 pi r. Now what this all means for us is that a full circle we know is 360 degrees or 2 pi r. That means 2 pi radians. So 360 degrees or 2 pi radians. A half a circle we divide by 2 means that's going to give us 180 degrees or pi radians. The other way that you can think about this is that 360 degrees equals 2 pi radians. And 180 degrees equals pi radians. That means if we want to convert back and forth between the two, to go from degrees to radians, we are going to multiply by pi over 180. And to go from radians to degrees, we are going to multiply by 180 over pi. Answers should typically never be given as decimals. You want to keep the pi in there and you want to keep them as fractions. So first example, I'm going to convert from degrees to radians. Now, I'm going to be multiplying by a fraction, so in order to make this a little bit easier, I'm going to turn these into fractions. So that's 60 over 1. To go to radians, I'm going to multiply by pi over 180. So that's going to give us 60 pi over 180. And then all you do from here is just simplify. So if you have no idea how to simplify this, the first thing you can realize is 60 and 180 both end in 0. So I can divide by 10. That's 6 pi over 18, which will simplify down. Both are divisible by 6, so that's 1 pi or pi over 3. So 60 degrees is equal to pi over 3 radians. I'm going to do the same thing with my second one. I'm going to start by putting negative 315 over 1. Doesn't matter that this is a negative angle, doesn't change the process. And I'm multiplying by pi over 180. So this is going to give us 315 pi divided by 180. Now you might be struggling with, what do I do to simplify this? Now you can go through and you can see that both are divisible by 5 and start that way, or you can think about both of these are actually divisible by 45. That's the biggest number that goes into them. So this is going to simplify down. 315 divided by 45 is 7 pi. 180 divided by 45 is 4. 7 pi over 4. The more that you do these, the quicker it's going to be to simplify. You're going to start to learn which divides first. All right, for my second example, converting to degrees, I am going to multiply by the reciprocal. So I'm going to multiply by 180 over pi. And what you'll notice that I tend to do when doing these problems is I simplify as much as I can. So for example, I have a pi in the numerator, I have a pi in the denominator. Those are going to cancel very easily. And then I keep simplifying from there. 18 and 180, 18 divided by 18 is 1, 180 divided by 18 is 10. Basically, you have 23 times 10, or 230 degrees. Second one, I'm going to start the exact same way. I'm multiplying by 180 over pi. First thing that cancels out very easily are my pi's. From there, 6 doesn't go into 11, but 6 does go into 180 30 times. You're left with negative 11 times 30, which is an angle of negative 330 degrees. All right, and lastly, the thing that we need to talk about once again are our quadrantal angles. So 0 degrees is going to be 0 radians. Pretty self-explanatory. So I'm also going to start at 0. 90 degrees, when you convert it, is going to give you pi over 2. Now, we know that every quadrant is 90 degrees or pi over 2 radians. So if I wanted to go up to 180 degrees, I would add, because I have 2 of them. So that's 2 pi over 2. But we don't leave that like that because that can be simplified down to just pi, which makes sense if you think back to the first thing we talked about. 180 degrees equals pi radians, a circle. For 270, remember that's 1, 2, 3 90 degrees, so that's 3 pi over 2. And then to get 360, that's 4 of them, that's 4 pi over 2, which once again, we don't leave it like that, 2 pi. So the last type of example we're going to talk about, draw the angle in standard position and list which quadrant it lies in. Draw the reference angle with a dotted line and find its measure. Now there's a couple of ways you can think about this. 2 pi over 3 is less than pi, and pi is half the circle, which means you know it's either going to be in the first or in the second quadrant, because this is less than pi, which is halfway around the circle. What we're going to do just for some extra practice is we're going to go ahead and convert this. So when I do that, I'm multiplying by 180 over pi. My pi's are going to cancel out immediately. 3 goes into 180 60 times. You're left with 2 times 60, which is 120 degrees. So we draw a 120 degree angle. 120 is going to be 30 degrees past 90. My angle lies in quadrant 2. Now, my reference angle, remember, gets drawn to the nearest x-axis. That would be this one here on the left. 120 is 60 degrees away from 180, so we have a 60 degree reference angle. For the second example, we have 7 pi over 6. 7 pi over 6 is more than pi, which means it's going to be down here in either the third or the fourth quadrant. It's just slightly bigger than pi, which means it's probably going to be in the third quadrant. So I start by converting. Multiply by 180 over pi. Just like before, the pi should cancel right away. 6 goes into 180 30 times. So you have 7 times 30, or 210 degrees, which makes sense because, like we said, it was going to be slightly past pi or slightly past 180. So I draw my angle in. Technically, remember, we have our initial side over here, but since it's always there, you can just draw it like that. Now, in this case, we are in quadrant 3. And our reference angle, we are still going to go to the left part of the x-axis, but we're going to draw up this time. And we're going to ask the question, how many degrees past 180 is 210? That's 30 degrees. So we have a 30-degree reference angle.